Hi all, welcome to the channel. Today we will be looking at day 3 of the October LeetCode challenge. The name of the problem is K-diff pairs in an array. So let's look into the problem. So the problem says given an array of integer numbers and an integer k, return the number of unique K-diff pairs in an array. The K-diff pair is an integer pair nums of I comma nums of j where the following are true. So ij is greater than equal to 0 less than nums dot length, so it's between the range of the values in the array. I is not equal to j, a should be less than or equal to b, and b minus a should be equal to k. So if you see here, it says that the return the number of unique k-diff pairs. So the pairs should be unique. So let's take the example 3 1 4 1 5. So here k is 2, so the diff between the two numbers should be 2. So 3 and 1, if we take 3 and 1, the diff is 2, but there is a 1 here as well. So this cannot be used because it's mentioned that it should be unique k-diff pairs. So we cannot use 2 3 comma 1, right? So 1 is 3 comma 1, and then there is 3 comma 5 as well where the diff is 2, the diff equal to k. So 3 comma 1 and 3 comma 5 are the two numbers, so the output will be 2, right? So here, right, this is the same example from LeetCode. So here if we take the brute force approach, right, that means I need to check what are the two numbers which is having the difference as k. In this case the difference should be 2, such that here a should be less than or equal to b and b minus a should be equal to k, right, and I should not be equal to j. So these are the three conditions, right, which we have to focus on. So if I write this number, right, 3 1 4 1 5, okay. So as a brute force approach, right, I can have two for loops, so one with a pointer I and the other with pointer j, right, and j will be always greater than I because I should not be equal to j, right. So j should be always looking forward and should be greater than I. So for each value of I can check the next values of j, right. So when I is 0, right, so let's say I is and j, right. So when I is 0, I can check for j equal to 1, and this index is 0 1 2 3 4, right. So it's still 4, right. So for j equal to 1 2 3 4, then when I is 1, I can check with j equal to 2 3 4, and then when I is 2, I can check with j equal to 3 4, okay. When I is 3, I can check with j equal to 4, okay. So these are the conditions, right, which I can compare for I and j and check whether the difference between those two numbers is equal to k, right. So let's say this is k1, right, this is the difference, actual difference. So when I is 0 and j is 1, right, so 3 minus 1 is 2, which is same as k, right. So this is a valid combination of I and j, okay. So 0 1 is nothing but this is the index value of I, so this is 3 1, okay. Now when I is 0, j is 2, 0 2, 3 minus 4 is minus 1, which is not k. Then when j is 3, 3 minus 1 is 2, again this is a valid combination, 3 comma 1. But if you see, these two are non-unique, right, we need a unique pair and these two are non-unique, so we cannot take this combination, okay. So then again j will be 5, this was for j equal to 3, for j equal to 2 it was minus 1, so this cannot be used, this is 2, but we cannot use this because it's a non-unique. When j equal to 4, it is 3 minus 5 is again 2, so we can take this combination 3 comma 5, okay. So that way we can go over and we can use two for loops. This is a brute force approach, and the only check that we have to do is we have to check for uniqueness, right. So for checking the uniqueness, right, what we can do is once the pair is found, right, we don't need to go over again, right, because what they have said is b minus a equal to k, right, which also means that if b is 3, okay, and a is let's say 1, right, 3 minus 1 is 2, right. So for any other value of a, right, we cannot have 2. So as soon as we get a value of 3 minus 1 equal to 2, so we get a pair 3 comma 1, we can directly break from there, because if there is any other value, that will be a non-unique value, that means that will be a duplicate pair, okay. So as soon as we get here for j, we can break it from here, then we can continue for the next value of I, right. So this is the brute force approach, and since we will be using 2 for loops, in the worst case there will be n square time complexity for that. So the brute force has n square time complexity. We can optimize this by using sort on this, right? What I mean by that is, if I sort this particular array, right? So if I sort this array, it will be 1 1 3 4 5, and let's say the index is like this. Okay, so once I sort this array and the condition is given as b minus a equals to k, right, where b is greater than a, right. So since b minus a equal to k, and this is in ascending order, right, so the values are in ascending order. So if I am at nums of 0, right, so the other pair I know it will be greater than this, right. So my current element will be the lesser value in this formula, right. So my current element will be a, right. So I have a, I have this k value which is 2, I know that. Now I need to find b in the remaining array such that b minus a equal to k. Okay, so from this formula I can derive that b is nothing but k plus a, right. So if I know a, if I know the value of k, I can try to find whether there is a number k plus a in this remaining array. If I get a number k plus a, then that is our b value. Okay, so since it's a sorted array now, I can very well search the number k plus a using binary search, right. So I only need to go over this array once in a for loop, and I can use the binary search to find k plus a, and since I and j should not be equal to same, so my binary search should start with I plus 1 always, right. So I can use a for loop, go over from I equal to 0 till, if it is n, if the, or let's say the length is length, so it will be length minus 1, right. I need to go till length minus 1, so actually it will be length minus 2 if I am including both 0 and length minus 2 range. Okay, because I need to check the next number onwards, right. So if I am at this position, since this is end, I cannot check the next number, so I need to go till this point, and then I need to do a binary search, my nums array starting from I plus 1. Okay, and the value that I will search for is nums of I plus k. This is the value I will search for. So let's do a dry run, right. What will happen if, let's say, counter is my count for the unique pairs that we found. So first I is 0, so at that point, so for 0 it will check whether I is 0 is 1, so my b value will be 2 plus 1 is 3. It will search in the array whether 3 exists. Yes, 3 exists, so counter will increment to 1, and the pair that we found was 1 comma 3. Now again, when I goes to 1, it will search whether k plus 1, 2 plus 1 is 3, 3 exists, is the same pair, right. So this pair won't be unique because we already found that, right. So to avoid that, what we can do is we can have a variable called previous variable and just need to check, since it's already sorted, we just need to check whether my current value of I, nums of I, is not same as my previous value. Okay, so here I can, let's say, my previous value equal to integer dot min value. Okay, and at the end of the for loop I'll always assign my previous equal to nums of I. Okay, so if my for loop starts here, at the end, before the end of the for loop, I'll assign my previous equal to nums of I. So that way, when I go to the next loop, my previous is now equal to 1. So since it is equal to my current value, I should not do the binary search in that case. So my count will remain same. Then my I will go to the next index 3. 3 plus 2 is 5, so that 5 is present here. Binary search will give me the value as 5 here. So this is a valid pair, so my count increases, and this will be 3 comma 5. Then my I goes to this index 4. 4 plus 2 is 6. 6 is not exist, so this will remain as 2, and then it will come out of the loop. So the output will be 2. Since we are doing one for loop, so here it will be O of n, and inside that we are doing a binary search. Okay, so in total it will be n log n time complexity. Okay, and we are not using any additional space, so time equal to n log n, space equal to O of 1. Okay, the code for that will look something like this. So first we are doing the sort here, I am declaring the variables length, count is 0, previous is my integer dot min value, and I just need to check in my for loop. I am checking if my previous is not equal to nums of I and if the binary search result is greater than 0. So binary search will give me an index of the value that we are searching for. So in my nums array I am searching from, this is my start value, so from my I plus 1th index till my end of the array. So this is important because it should not search for the same value, right? So if my k is 0, right, in that case the same number when it's subtracted it will give me 0, right? So it should not search from the same index value, so that's why it is index plus 1, and I'm searching for nums of I plus k. If that index value is greater than 0, that means I found that number in the array. In that case I need to increment the counter, and here I'm assigning my previous number as my current number, so that when it goes next time into the for loop it will again do the check for this condition, and at the end we will return the counter. So it's a simple code for NlogN time complexity. Now can we optimize this to O of n? Let's see how we can do that. So earlier NlogN was the time complexity, and NlogN was caused mainly because of the sorting, right? So to optimize this, that means we should not be doing the sorting. Okay, so how can we optimize this in O of n time without doing sorting, right? So let's see, can we use a frequency map here? So let's say if I use a frequency map, right, so let's say the key will be the value of the num size, so 3, and I will store the counter for this particular nums value, right? So this is my frequency map. So once I have the frequency map, right, based on this formula, now I have let's say this value is my a value, right? So if I have the a value, I need to find the b value, it will be simply a plus k, right? So once I have this value, I can find the corresponding pair by searching for this current value plus k, right? So once I build the map, building the map will cost me O of n, right? Because I need to go through this array once, right? Once I build the map, then I need to only go through the key of the map, right? So in worst case it will be again O of n, right, because all the elements can be unique, so it will be again O of n, right? And once I go through the key of the map, I just need to check whether the a plus k exists, right? So for a given key I will check if the corresponding a plus k number exists in the map, right? Now it can happen that k is 0. Now when k is 0, and if I search for a plus k, it will be same, a and b will be same, b equal to a, right? So let's say here in this case if k is 0 instead of k is 2, right? So for 3 I will search whether 3 exists or not, right? And 3 is already present in the map here, it will give true for itself, right? In that case we have to check whether the frequency is greater than 1. So in case of 1, right, since 1 minus 1 is 0 and I is not equal to j, this counter should increment to 1. So what we can do in that case is for example here in case of 1, if we check that 1 plus k, k is 0, so 1 plus 0 is 1, and we get the value of 1, we will find whether the value corresponding frequency is greater than 1. Here it is greater than 1, in that case we will increment the counter. Okay, so that way we can go over the map only once and find out what is the number of pairs that exist, right? So we will have the complexity as O of 2n, which is nothing but O of n. Okay, so the time complexity will be O of n. The space complexity, since we are storing the map, it will be also O of n here. Okay, so let's look into the code for this. So I have written down the code here. So we are declaring the map here and adding the elements into the map and building the frequency map. Once we have the frequency map, we will go over all the key in the map, and first we will check whether the k is 0. If k is 0, then the condition is that we have to check whether the corresponding value is greater than 1, the frequency is greater than 1. If the frequency is greater than 1, then increment the counter. The other condition is if k is greater than 0, right? In that case I just need to check whether the corresponding a plus k, right? So here I am doing k plus key, whether that corresponding pair it exists in the map. If it exists in the map, in that case I will increment the counter, and at the end I will return the counter. So let's submit this code, and the code is accepted. And as I said, the complexity for this algorithm will be O of n. So that's it for this video. Hope you liked the video. If you have any questions, please write down into the comment section. Thank you.